Hi folks, we're going to take a look at the solutions for the open response questions from the winter 2008 practice EQAO booklet. Okay, so let's start with number 5. Okay, now I'm also going to be specifying how you should be showing your work, okay, because you don't need to show a lot of work in these questions, but you want to make sure everything is very clearly indicated so you get full marks on the question. Okay, so here Sam's interested in buying a TV. And you've got the TV is $599.99 at one place, $899.99 at another place. Okay, it's on sale at 20%. Here it's on sale at 30%. And what's important to always read is what exactly they're looking for, because here it says what is the difference in the sale price of the TV between these two stores. Okay, so they're not just looking for the prices, are also looking for the difference in the price. So you got to make sure you read the question carefully so you actually give them the answer that they're looking for. Okay, show your work. Okay, so what I'm going to do is I'm going to split this up into two sections. So first I'll do fair deal, and again if you write FD for fair deal, you know, they'll understand what you're doing. And so I'm going to calculate the sale price of the TV at fair deal. So regular price is $599.99 and it's on sale at 20%. Now there's two ways of solving this. You can first find the discount, so do 0.20 times $599.99 and then subtract it from the original amount. That's sort of the two-step process. Or it would be good if we could start to get used to doing this as a one-step process. So if we're taking away 20% off the price, because that's a discount, what's left is 80% of the original price. So if we want to do this in one step, it's a matter of finding 80% of $599.99. So what I'm going to do is I'm going to calculate 0.8 times $599.99, okay, to get the sale price. Okay, now if you did do it the other way, it's perfectly fine. There's nothing wrong with it. It's just, you know, a little longer. So here, let's calculate 0.8 times $599.99. Okay, and we have $479.99. Okay, so the price here is $479.99. That's the sale price. And now let's do the same thing for the other place. So big discount. So B, D. Okay, and I'm going to do the same thing here. Instead of first finding 30% and then subtracting it, I say, well, if I'm losing 30% of the cost, because that's the sale, I'm left with 70%. So I have to do 0.7 times $899.99. Okay, and let's see what that gives us here. 0.7 times $899.99 equals $629.99. Okay, and so now the last step is to actually find the difference. So the difference, okay, and I'm going to indicate exactly what I'm looking for, and I'm actually going to write down the subtraction. Okay, just in case I make a silly mistake, I want to show the grader that I know exactly what I'm doing. So I'm going to subtract $629.99 by $479.99, and we get a final answer of, always leave it on your calculator, minus $479.99, and we get $150. Okay. Okay, so just to recap the solution here, first I found 80% of the full price, that's 100% minus the 20% discount, then 0.7, 70% of $899.99 to find that sale price, and last step is to subtract them to get the difference, which is what we're looking for. Okay, let's move on to the next one. So the next question here is number 9. And it gives us some data. In this case here, it compares the average March temperature to the latitude of the community. Okay, so the average March temperature for 6 Ontario communities are plotted according to their latitudes on the scatter plot, and let's see what they ask us. They give us that Kenora has a latitude of 50 degrees and an average March temperature of negative 6.3. Does the community of Kenora follow the trend of the data? Justify your answer. Okay. Now, when we look at this data, well, it's clear that it's not perfectly linear, but it does seem to be somewhat linear, okay, because for the most part, as the latitude increases, so that means as I go further north, the average temperature seems to be going down. Obviously there's one outlier here that doesn't quite follow that pattern, but for the most part the pattern seems to be followed. Okay, so the first thing I'd want to do is represent this with a line of best fit. So remember, I want a line that's close to all the points, and I should try to get about the same number of points above the line as below the line. So I think if I draw something like this, okay, that's a pretty reasonable line of best fit. So as long as you draw something that's reasonable. Okay, so I've got 3 points above the line and 2, well, this is just right about on the line. Good enough, since that one's very close anyways. Okay, so what I've done now is I've used this linear model to represent the relationship. Okay, even though it's not perfectly linear, it's pretty close. Okay, so now what we want to see is if this data fits the trend. Okay, now remember, it doesn't mean that this data needs to be exactly on the line, but it needs to be pretty close if we're to say with some certainty that it follows the pattern. So here we have a latitude of 50. Okay, so I'm going to go to 50 and negative 6.3. Well, negative 6.3 would be, if that's negative 7, so here I go down 50 and 6.3. Well, that's almost, it looks like it's actually right. Oops, 6.3 is maybe a little higher. My point is pretty much on the line. Now, in order to show my work nicely, I'm just going to put a K here, or I can even say that this point represents Kenora. Okay, be very clear about what I'm doing. And since this point actually lies on the line of best fit, okay, I can say that yes, Kenora does follow the trend in the data. Now, even if I had drawn my line a little differently, Kenora would have been very close to that line if I drew a good line of best fit, and I could have made the same conclusion. So here to justify the answer, okay, so you can say from the graph, okay, we see that the point representing Kenora, okay, lies on the line of best fit. Lies on the line of best fit. Okay, now had it been close, I could have just said is very close to the line of best fit, and I can make the same conclusion. Therefore, Kenora does follow the trend. Shown in the graph. Okay, or I should say shown in the data. Okay, it happens to be given in a graph. Okay, so the steps here definitely were to draw a line of best fit, to clearly indicate the point that represents Kenora, and to see that that point lies either on the line of best fit, or if not, would be very close to the line of best fit. Hence, it does follow the trend in the data. Okay, so those are the 3 components you need: the line of best fit, the point clearly indicated, and then the conclusion based on what you see. Okay, so I'll just kind of show the answer there before I move on. All right, let's move on to the next one. So this one here, number 15, washed up on the shore. Okay, so here we have a boat traveling from point C to point D, which is on the shoreline. The shoreline is represented by the line through points A and B. So there's the line, and it says determine whether the path from C to D is perpendicular to the shoreline. Justify your answer. Okay. Now, if you look at these 2 lines, they look pretty perpendicular. Okay. Now, you might be tempted to use a protractor. Okay. In fact, just to show you that, okay, you could use a protractor. So let's put it on one line. And when you actually put the protractor, if you can sort of see, it's not exactly perpendicular. Okay, so if you were to make the conclusion based on using the protractor that it wasn't perpendicular, or even that you say, well, it's pretty close, so I'm going to guess that they are perpendicular, you know, that would be a level 1 response, okay, maybe level 2, but you have to keep in mind that these diagrams are not necessarily to scale. The other issue that we might have is, well, what if the scales are not the same on the x and y axes? That always messes things up. Now in this case here, they are the same, okay? So the way to solve this problem correctly is to do it analytically, and that's really what you're expected to do here, is solve this analytically. And of course we know that the relationship between two perpendicular lines is their slopes are negative reciprocals of each other. So it's a case where we have to determine the slope. So let's determine the slope of AB. Okay, and notice when I'm determining a slope, I have to specify which slope I'm looking for. I'm not going to use M for both of them. So here I could write M and AB to show that I'm determining the slope of that line. Or you give yourself a title, whatever you like. Okay, but you have to be very specific of what you're finding, and you want to show your work. So if you need to do rise over run, you can certainly do that. Or you could subtract the y's and divide that by the subtraction of the x's. Either one of it is fine. Just make sure you show your work. So if you're using rise and run, show it on your graph. Okay, I'm going to calculate analytically. So I'm going to do this, make this the second minus the first. So here we've got 7 minus negative 5. That's y2 minus y1. Okay, remember it doesn't matter what order you go in as long as you follow the same order, numerator and denominator. So I have to follow the same order, 0 minus 8, because these are the 2 points I'm working with, so 0 minus 8. Okay, so what do we have now? 7 minus negative 5, that's 7 plus 5 is 12. 0 minus 8 is negative 8. So here my answer is going to be negative, and I can reduce this. Okay, they're both divisible by 4, so 12 divided by 4 is 3, and 8 divided by 4 is 2. So there's the slope of AB, and now let me see if the slope of CD is the negative reciprocal. Okay, so again, you could use rise over run. You would show that on your graph, but I'm going to use the formula. Okay, so let's do negative 5 minus negative 8. So that's y2. Oh, sorry. These are the 2 points. Be very careful. See, I almost made that mistake. These are the points you're using. So here, negative 2 minus negative 8 divided by, so I started here, I'm going to have to start there, 6 minus negative 3. Okay, so negative 2 plus 8 is going to give me 6, and 6 minus negative 3, 6 plus 3 is 9, and of course these are both divisible by 3, so 6 divided by 3 is 2, and 9 divided by 3 is 3, so 2/3, and I see that they are negative reciprocals of each other. Okay, but if I just leave it at that, all I've done is I've calculated the slopes. I need to justify my answer. I need to say why this means that they're perpendicular. So I could write a sentence, you know, they're perpendicular because they're negative reciprocals of each other. I'm going to use more symbols. I'm going to say they are perpendicular since, okay, and I'm going to use that relationship. They're negative reciprocals of each other. I can write that by saying that the slope of CD is negative 1 over the slope of AB. Okay, negative reciprocals, okay, which can be seen here. Okay, so again, step number 1 is to realize that you should be doing this problem analytically, not by using a protractor, and you do that by finding the slopes of both of the lines and then showing that they're negative reciprocals of each other, and don't forget to write a justification since that's what they're asking for. Okay, that's it for this one. Let's move to the last open response question. Okay, here we have cone zone. So Zach measures the slant height of a cone-shaped cup, finds that it is 12 centimeters, the height is 10 centimeters. Determine the volume of water in the cup if Zach fills it to the top. Show your work. Okay, so first thing you would do, since you don't have to memorize it, is you check your formula sheet to find the formula for the volume of a cone, since that's what we're working for. So the first thing you do is look up the formula, or if you happen to know it, and the volume of a cone is just 1/3 the volume of a cylinder with the same radius and height. So it's pi r squared h, the volume of a cylinder, divided by 3. Okay, so the problem is that you're missing one of the components of your formula, is you don't know the radius. Okay, so let me give it a name here, and here you realize that the relationship between the radius, the height, and the slant height is a right angle triangle, and since you know two sides, you can use Pythagoras to find the third. Okay, so what I'm going to use to find radius is Pythagoras, so r squared plus 10 squared is equal to 12 squared, of course, since 12 is the longest side. And now I'll solve for r. So r squared is equal to 12 squared minus 10 squared. And so r is equal to square root of 10 squared. 12 squared minus 10 squared. Okay. Now, you can calculate r, and I'm going to do that. But you might also notice that what you have in your equation is r squared. Okay. So you actually don't need to calculate r. Okay, if you did, that would be fine. Okay, so here we have square root of 12 squared minus 10 squared. Okay, make sure if your calculator does not open brackets automatically that you do it. Okay, and we get 6.63. So I can use that for my radius, or I can realize, okay, that r squared is just equal to, well, 12 squared is 144, minus 10 squared is 100. So there you go, 44. So again, you don't actually need to find r directly. Okay, so let's now put the information we have. So again, for pi, you can use either 3.14 or the pi button on your calculator. Either one is fine. So we know r squared is equal to 44. Now again, had you put 6.63 squared into the equation, that would have been perfectly fine. The height, now when we talk about the height, remember it's the perpendicular one, so it's the 10 centimeters. Okay, and also the fact that they tell you in the question the height is 10 centimeters, and all that divided by 3. Okay, so let's go ahead and calculate this. So I'll use my pi button, so pi times 44 times 10 divided by 3 equals 460.77. Okay, so here we have 460.77. Okay, and since this is my final answer, now I have to put in the units. So I see everything's in centimeters. So since it's volume, it's centimeters cubed. Okay, and there's my answer. So just a quick recap. Okay, we have to find the volume of the cone, look for the formula. We realize that we're missing one of the pieces of information. That's the radius. I notice that I have a right angle triangle. Use Pythagoras, and then input that into the formula to get my final answer. Okay.